Hello everyone, welcome to Engineering Archives. Let's look at our learning example number 8. This is going to be our learning example number 8. So here's a problem that says if force F is to have a component along the u-axis of 6,000 newtons, determine the magnitude of F and the magnitude of its component Fv along the v-axis. So here we see the force F, and they have given us a set of axes that are once again not perpendicular to each other. So we are going to use the vector triangle method. So they have given us the component of this force along the u-axis, this component, and this component of the force F is 6,000 newtons. And they want us to find the magnitude of the force F and its component along the v-axis. So in order to do that, we need the vector triangle. So let's start with that. So the most easier vector to draw would be the 6,000 Newton vector, since it's directly upwards. So let's draw that first. Newtons. Alright, we know that the component along the v-axis is like this in this direction. So let's draw that. Something like this. And lastly, we know that the vector for the force F is like this, and it makes an angle of 45 degrees with its u component. So let's just extend this a little bit downwards, and now let's draw the force F vector like this. Now keep in mind that we have followed the head to tail rule, and that rule says that the tail of the resultant vector, which is the force F vector, needs to start from the tail of the first vector, and needs to meet the end of the second vector, just like in this vector triangle. So let's put in the angles now. We know that this angle is 45 degrees, which is also given in this diagram right here. This angle, we can get this angle from the diagram too. This angle is the angle between the component of the force F along the v-axis and the component of the force along the u-axis. So this angle would be this angle right here. If I extend the v-axis upwards, this is the angle that we need, since this is the angle between the u-axis and the v-axis. Now if we look at all these angles at the same time, we come to see that they should all add up to 180 degrees, since this is the v-axis and it's a straight line, and the force F is like this, while the u-axis is like this. So all the angles on one side of a line should add up to 180 degrees. This is 105 degrees. This should be a little bit like this, but since this diagram is only for illustration, that's okay. And this angle, as given in the diagram, is 45 degrees. While we need this angle would be this angle right here. So subtract 45 and 105 from 180 degrees, and the answer that we get is 30 degrees. So this angle would be 30 degrees. Lastly, to get this angle, simply subtract 45 and 30 from 180 degrees, and we get 105. Or alternately, you can also find this angle from this diagram right here. That angle corresponds to this angle, which is 105 degrees. Now that we have our vector triangle, to find the magnitude of the component of force F along the v-axis, and to find the force F itself, all we need to do is simply apply the sine rule. So according to the sine rule, F over sine of 30 should be equal to 6000 over sine of 105 degrees. And the value that we get for F is equal to 3105.83 newtons. Similarly, solving for the component of F along the v-axis, we get FV divided by sine of 45 degrees equals to 6000 over sine of 105 degrees. And the value that we get for force of F V component equals to 4392.3 newtons. So this is the simple and easy method that we have been doing in previous problems too. Thank you very much. See you in the next video.